Welcome, friends. So today we are going to discuss the next phase of DMAIC model of Six Sigma deployment, that is measure phase, and we are going to see what are the stepwise procedure to implement measure. We have seen in the previous video what is the meaning of define phase and how to implement define. Today we'll proceed with measure, and what we have seen earlier I'll show you that we have seen what is defined, step A, step B, and step C. Now we are in on step 1, 2, 3, that is select the CTQ under measure phase, define performance standard, validate the measurement system. So what do I want to improve? What is the best way to measure it? And can I trust the output data? So this is mainly if I am having a measurement system and all my things are dependent on measurement system. So we have to check our measurement system whether my measurement system is working satisfactory or not, because sometimes we may reject a right project or a right product because of wrong measurement, and sometimes we can accept a wrong product because of wrong measurement as a right product. So we have to be careful, we have to analyze. We cannot control completely the measurement system, but to the extent to you can say to the zero level defect we can go for it. So let us proceed further. What is going to be under this phase of measurement? So under this we are going to see that how to select CTQ characteristics. CTQ means critical to quality. So why a characteristic will become critical to quality? That means critical to quality means something that will become important to customer. So what is important to customer and how to convert it CTQ, that we are going to see here today. So we can identify measurement of CTQ, measurable CTQ characteristics, and how we will improve it. That is going to be mainly the target of any Six Sigma project. That is how to improve CTQs. So what the CTQ is exactly, we are required to find it out. Define performance standard. Develop operational definition for the process to be measured. Identify target performance. Set a specification limit. Define unit defect and defect opportunities. So what is expected out of the process? What is going to be the performance standard for the process? What level of defects are going to be acceptable? What are the specification limits that we are going to see here under defined performance standards? Establish data collection plan. Develop data collection plan, collect the data plan, how much a sample is to be collected, from which shift you are going to pick up the data, how you are measuring the things, what you are taking measurement, and at what frequency you are taking measurement, and who is taking measurement. That all is basically the planning. Validate measurement system. Once we have a measurement system, ultimately the main target of the MSA is our measurement system analysis. That is what is the target of measure phases, MSA, measurement system analysis. So we have to validate that my measurement system is satisfactory working, it is not faulty, and I am not going to accept a wrong product because of my measurement system, and I am not going to reject a right product because of my measurement system. So that is what we have to do before we do anything at the major level. So how we'll be picking up some of the tools which we can use here and explaining you. You can implement it, start doing yourself, as I suggested you earlier. Uh, how a need become a CTQ, that is very important. How a customer need can become a CTQ. So customer need can be any vague thing, anything which is not well defined. We have to identify what is the characteristic of that thing, what is the unit we wish to measure, what is the target value, what are going to be upper and lower specification limits, because target is not going to be always met, what is the desired quality level. So this all combinedly will define CTQ. Okay, so critical to quality parameter is what is critical to quality parameter. Maybe the temperature at which you serve the coffee or the tea in the restaurant, or the temperature of the pizza delivered at home, or maybe the minimum level of output results expected from the students in a particular subject, or maybe any kind of parameters, whatever you can measure, but it should be measurable and properly accountable kind of thing, characteristic. Some of the tools to prioritize or define CTQ. There are some tools we use to prioritize CTQs. There are some tools which we can use to prioritize CTQs. These tools are QFD, quality function deployment, process mapping, cause and effect diagram, failure mode effect analysis, and Pareto charts. These are the 4 major tools which we use to prioritize that this CTQ to be selected. We cannot attack on all the CTQs, because every of the CTQ, if you do a Six Sigma project, it is going to cost you something. It is going to cost you money, it is going to cost you time, it is going to cost you labor or your manpower. So we can select what particular CTQ is important from the purpose of profit maximization or reduction of the losses. So these 4 are the major tools what we use. I will be giving you a little bit introduction of all these tools here, but in detail we will be separately discussing the Six Sigma tools. So let us proceed further and have a little bit introduction of all these tools. Say first one is flow chart. Flow chart is nothing but a graphical representation of the step involved in a process. Flow charts give in detail the sequence involved in material, machines, and operations that are involved in the completion of the process. Thus, they are excellent means to document the steps that are carried out in the process. So it gives a very clear pictorial view of what is happening. So there are some symbols what we use, like we have used oval to start or finish. We have used a rectangle for operation, right? So decision making, we have a different kind of symbol. So there are different kind of symbols we use. This is just to lay down in a block that how the work is happening, how the work is progressing. This is very important. This is very important because it can help you. These are the some of the mapping symbols we use: process step or operation, delay, quality check or inspection, storage, decision, transportation, or movement. These are some of the symbols we use. We can use these symbols or we can use any of the symbols. If you pick up, most of the softwares are having inbuilt symbols. You have to pick up the symbols and put it there. You can automatically make the process diagram sitting on a system. Okay. Now, what is the problem issue is basically when we are discussing here, say what we think that a process is something like this, right? It seems to be a little bit complex, but not very simple process. But actually, if you'll go into the depth of making the process map, you will come to know that it is actually like this. What is the difference? It's too complex. It's too complex. It is becoming very difficult. You cannot control the process. There are a lot of issues and delays are going to happen. Material is going to be wasted and time is going to be really wasted. So that is what this is actually. So once we start making the map, we expect it should be like this, but actually it is going to be like this. Few people will accept it or few will not accept it, but it is a fact of life. But our target is that it should be very simple, a straight simple flow, so that we can easily see what is happening and how we can control it. Okay, so this is basically happens when we start making process map. Pareto chart. Pareto chart is another useful tool we use to prioritize the CTQ, that which project is to be selected, which CTQ is to be used. Pareto chart is a vertical bar chart in which the bars are arranged in a descending order of their height, starting from left, and prioritize the problem or issue. Pareto chart is a formal technique useful when many possible courses of actions are competing for attention. The purpose is to prioritize the problem, to analyze the process, to identify the root cause, to verify the whatever important process you implement, continue to work. So basically, the value of the Pareto principle for a project manager is that it reminds you to focus on 20% of the things that matter. Of these things during the project, only 20% are really important. These 20% produces 80% of the result. Identify and focus on these first things first before moving ahead. So you have to focus on 20% of the issues which are accountable for 80% of the problem. We have to segregate it out and put our energy to attack on those issues, not on all the issues. So it is I'll move this techniques helps to identify top 20% causes that needs to be addressed to resolve the 80% of the problem. This is wise decision. Just put 20% of the causes and try to see how 80% results can be removed out of those 20% problem. Now those 20% is required to be selected wisely by us. This is an example of Pareto chart. Problem of students visually challenged student face in the classroom. So there are different reasons has been identified and survey has been conducted. You will come to know that BA and D, that is limited study material or giving exam. So there are some of the things which are causing 80% of the issues. So we have to focus on those 20% of the problem which are causing 80% of the issues, not on all the issues. Another tool to convert many vague requirement into CTQ is house of quality. Customer requirement, now you see there are different boxes. It's a shape of a house. If you see here, one is for customer requirement priorities, what customer want. You see the two is here, two is competitive product evaluation. We compare our product with the competitor and try to see what competitor is doing. 3, for the particular requirement or the characteristic I am talking. So in one you will have 8 to 10 characteristics. For each we are going to see what others competitor is doing. Then 3 is engineering characteristics. 3 is trying to see what is the relevant engineering characteristic, because what customer is telling is not the CTQ. What is the engineering characteristic, what we can measure is the engineering characteristic. Number 4 is relationship between 1 and 3. So 1 and 3, what is the relationship existing, that is given here in some numerical value. You can give 135 or you can have some kind of a scale. Relationship between engineering characteristics come here because maybe one characteristics improve, others reduces. So you can have positive correlation, negative correlation, neutral kind of correlation between characteristics. Because if I want to improve one characteristic of engineering product, other may be worsen. So that is what we have to do. Then finally, the 6 is the target for my new product. Now we are not going into the detail of this, but this is what house of quality looks like. We'll be making a separate video to understand that how to make house of quality. Cause and effect diagram is another tool which is used to prioritize what CTQ is to be taken, and even it will start giving you solution for the next phase, that is analyze phase. And this is developed by Ishikawa in 1943. It is known as Ishikawa diagram or even fishbone diagram or the cause effect diagram, all are same. This diagram is helpful for representing the relationship between an effect and the potential of possible cause that influence it. It is very much helpful when one wants to help find out the solution of a particular problem that could have a number of causes for it, and when it was interesting to find out the root cause of it. So it's help you to understand and focused on the particular problem, and associated CTQ can be analyzed and improved. So it looks like this. Effect can be dependent on different things: man, machine, material, mother nature, pupils. So the purpose is, this is effect of Y, it is dependent on X's. We are focused in Six Sigma to find out X's and focus on X. So we use this tool basically in measure as well as analyze phase to find out the real problem issues. Suppose this is an example. A man has broken a cup in a sink. What? And this is the output. This is a cause effect diagram. We have analyzed man, method, cups, and sink. So cup, what can be the problem? Method can be wrong. What can be the problem with the man? What can be the problem with the cup? What can be the problem of the sink? And then we focused on what is the major cause of the problem. Just attack on this. Don't maybe wash off his hands. It's major issue. He is not washing the hand. That is only the reason, because no, never earlier cup was broken, or he was washing too quickly to go out, or some of the appointment was there. So that can be number of things. So this is an example. You can make an n number of such kind of diagram yourself to solve your problem. FMEA is another tool, failure mode effect analysis. Identify the way in which one process cannot meet the critical customer requirement. It funnel out or reduces the axes which are required to be focused, rank the items we should work on first, identifies holes in the control plan, leads us to ask more detailed question about how the axis produce defect in the process. It again prioritizes the axis or the action plan. Now in FMEA, what we use RPN number, risk priority number. The output of FMEA is RPN. RPN is a number which comes out of severity multiplied by the occurrence multiplied by detection. So how severe is the failure, if something will fail, or what is the occurrence of failure, and what is the detection possibility of detection if a failure occur. So combinedly these three things multiplied, and then you get the what is the RPN number and the things to be done which is having higher RPN number. Severity is the importance or the effect of the customer requirement. Again, you can have rating from 1 to 10. Occurrence, how frequently that kind of failure is occurring. So it again you can have a scale 1 to 10. And detection, we can rate it again 1 to 10, whether we are able to detect it properly or not. We are in the proper well-defined manner. And this is what FMEA will look like. We have to see the process step. We have to write down here the complete step of the process. Then try to see what is the failure mode, what is going to be the effect of failure. Then we write down here severity in 1 to 10 scale. Similarly, what is the potential cause? Again, we have occurrence frequency. Again, we have current control system. Are we able to diagnose or identify, detect the issue? So again, we have 1 to 10 scale. Then when we'll have our RPM for different things, and we'll select which RPM is high, that is going to be a critical issue to be solved, and that project is to be taken first. That CTQ is to be attacked first. Operational definition. What is the operational definition? Operation definition gives the communicable meaning of a concept by specifying how the concept is measured and applied within a particular set of circumstances. It gives a precise meanings to the spoken or written words, forming a common language between two or more people, because what customer says, the same language I should follow. An operational definition is a description of something where those affected have a common understanding such that all parties involved experience no ambiguity over what is being described. Element of operation definitions. There are three elements: criteria, test, and decision. Standard against which to evaluate result of the test, procedure to measurement of the characteristic, and decision is determination whether the test result shown the characteristic meets the criteria or not. So we have to do all these three tests. Develop an operational definition. We want a 50% wool blanket. Now this is what the customer says. Criteria is wool fiber evenly distributed and comprise half the blanket weight. 50%, that is half the blanket weight. Test, analysis of sample measures distribution and proportion of the fiber. We are going to test it. Then decision, wool fiber evenly distributed and comprise half of the weight. Blanket, it is 50% wool. So this is how we define any definition into operational definition. That is very important for the point of view of quality. You can use checklist, record the data for further analysis, historical records, and data collection method. Checklist is very important, and you have to get used to you do checklist. It's a common sense basically to use the checklist. Performance standards. There are few things what we must know. Unit is the item produced. Defect is an event that does not meet the specification of a CTQ. Defect opportunity is an event that can be measured that provide a chance of not meeting a customer requirement. Defective is a unit with one or more defects. So defect is an defective may have many defects. A defective product may have many defects. We are focused on defect. We are supposed to reduce the defect. Customer need, we convert into CTQ, then CTQ we try to see what is the product characteristic, how we are going to measure it, what is going to be the target value, and what is going to be the specification limit. Okay, so cycle time to deliver a drawing, for example, you wish to give a drawing to it, from notice to the proceeding of the delivery time to the drawing measure, we have to measure it in weeks. Target 13 weeks, specification plus minus 2 weeks, 15 weeks. So this can be a good way to completely understand how customer need is to be converted into performance standard for the operators or the persons in the company. Now another thing is we have to talk about the data. There are two kind of data. When we talk about the data collection, we have to be careful that there is attribute data and the variable data. Variable data is something which we can measure continuously using some measuring systems like tensile strength, diameter of a system, length or something. We have to, it is a continuous in nature. But attribute data is yes, no kind of data, pass fail kind of data. So variable data give you more information, but it takes more time to test and record the variable data. So when you are going to plan MSA or measurement system analysis, when you are collecting the data, you have to be careful which kind of data you are going to take, because variable data, if you collect, it will have higher inspection cost. It will have, but it will give you more information. Whereas attribute data will have will give you less information, but it will have it also have less cost of inspection involved. So data type is critical. Be very critical. You have to be see precisely that you can measure it. Your data can be continuous or discrete. Continuous means it is you can divide it, and you by do two, if you do something, you will get a feasible number. But if discrete is something which comes after some time, so less information is available from discrete data and more from the continuous data. I have already told you, and ultimately we have to convert it into some kind of maybe curve, associated curve. We can use various kind of tools to see the variation in the type of data. So discrete data and continuous data, variation for a period of time, variation over a period of time. So this is how we have classified it. So discrete data for a limited period of time, we can use Pareto, bar and pie chart. For continuous, we can use histogram, box plot and multivariate chart. We can use it with Minitab or any of the good software of a statistical analysis. For variation over time, we use run chart, control charts, P chart, C chart, U chart, individual measurement chart. Continuous data, we can use run chart, control chart, individual measurement chart, X bar R chart. So we'll see later on what are these all things. But yes, these are the tools. You can have summary of this all, what we can do it, because measurement is very important. And our purpose of Six Sigma measurement system is to see that overall process variation is basically the actual process variation plus measurement system process variation. We have to see that measurement system variation should not be more than a particular limit. Otherwise, maybe my measurement system itself is the problem of or the reason of the observed process variation. So possible source of variation: actual process variation and measurement process variation. Actual process variation can be long-term, short-term variation or within the sample variation. Measurement process variation is variation due to gauge, variation due to operator, and variation due to source environmental. So variation due to gauge can be repeatability, calibration, stability, and linearity. That is, we are going to discuss in detail. Normally in all Six Sigma black belt kind of course, we go into the depth and analyze this system and try to see that measurement system is not having the problem in repeatability, calibration, stability, and linearity. And this is what we used to do, collect the data, and finally we try to see that overall process variation is how much of my measurement system is causing my process variation. Reproducibility means appraisal variation, the variation in the measurement attributable to the different appraisal using the same measuring instruments. That is, other person is using and variation is coming. Repeatability is same equipment, same person is using after some period of time, whether it is after repeating, whether the things are coming right or not. There are some tools, gauge R&R we used. We can use it directly in Minitab. We can use two-way ANOVA. We can use percentage tolerance, percentage contribution, percentage steady, distinct categories for continuous data, and percentage repeatability, percentage reproducibility, and percentage accuracy for attribute data. So this we use with Minitab. We collect the data, do the measurement system analysis, and try to see whether my measurement system is not causing the problem. That is the fundamental of this, and we will be having more detailed description on this later on. Once we are through with complete cycle of DMAIC, then specific tools I will tell you. See, this series of Six Sigma lectures are especially for medium, small level of industries, those who do not want to invest on the training, but they want to get the benefit out of it. Start doing. Take the trial version of Minitab and try to start doing this, implementing the project management skills of the Six Sigma. And I'm stopping here. Wish you all the best, and I hope that you have enjoyed and learned something out of this session. So I expect that this is going to be valuable learning for you, and definitely if you have any issues and problem, and suppose you want to go beyond Six Sigma with innovation, which is having less of the resources, then you can definitely write to me, you can contact me, and we are in process to develop Six Sigma with the innovation tools, so that it is not going to be that costly, it is not going to be that rigorous, but do understand what the Six Sigma is. It is not a failure, it is really successful. It all depends on how you use it. If you are smart enough, you are going to get the result. If you are not using it smartly, rightly, or manipulated data has been used, you cannot get the result. It's all the play of data, and actual work will come if your actual data is really good. Wish you all best of luck. Thank you all for listening to me, and I will be stopping here and meeting again with a further series on the further lecture on this series. Thank you all, and I'm wish you all the best once again. I'm stopping the presentation. Thank you.